the first thing we're going to do is just be changing forms. We're going to be changing it to exponential form and logarithmic form. So not calculating anything, just changing the way it looks. Okay? So what I want you to do is write log. I want you to write, we'll start with this first one, 3, 9 equals 2. Kind of just rewrote the first problem over here. This is logarithmic form. How can you tell? Because it says log. Okay? The 3 is what we call the base. So the small number beside log is always going to be your base. The 2 is the exponent, which will come in handy when we write it in exponential form. And then the 9, I just want you to put equals. You'll see why in a minute. So always remember the little number is the base, equals exponent. Base, this is the equal, this on this side is the exponent. So when we're writing this in exponential form, we're going to write 3, always start with the base, raised 2. Raised 2 is talking about exponent. And then that's why I put equals, because it's going to equal this number. And then all you have to do to check it is check if this is a true statement. Is 3 squared 9? Yep. You're done. So this is logarithmic form, this is exponential form. Same equation, just written 2 different ways. So what is the base in this problem? 10. Good. The smaller number is always the base. What's the exponent? So 10 to the negative 2 equals what? 1 over 100. Is this true? Yes, because negative exponents, remember, that's why I put these in your math workshop. Negative exponents, you got to move them to the bottom, right, to make them positive. What would 10 squared be? Notice how it's on the bottom. So it's true? Yes. All right, do number 3 and 4 on your own. All right, Miles, what'd you get for number 3?
I got B. The third equals 64.
Very good. Everybody else got that? This one's different because you can't really check to see if it's right. But what would B have to be? B have to be? Yes. Why did you say that?
I use the math button on here.
No. Tell me how you know. Because 4 cubed is what?
64.
So write B equals 4. What you just did was evaluate a logarithm, which is what we're going to do down here, but we're just practicing up here.
So do we have to write the B for this problem?
Not if it just says write it in exponential form. This was just practice for down here. This is the right answer.
Okay.
Darian, tell me the next one.
5 squared equals
So what is X?
25.
Very good. Again, this is just practice for down here. This is the correct answer. So everybody's good with writing logarithms in exponential form? Yes. Okay. Moving on. Now we're going backwards. It's in exponential form. We're going to put it in logarithm form. So remember, the base always goes first. Log of base. So this is going to be log of what? 5. The equals goes next. So it'd be of equals. That's it. Let's do number 7. And then I'll let you do 6 and 8 on your own. It's going to be log of what? E. Next number?
9
Equals? Perfect. Do 6 and 8 on your own. Alright, Alyssa, what'd you get for number 6? Good? Everybody agree? Ransom, what'd you get for the next one? What's the base here? Good. 27 is the base. What goes next? Equals. So the exponent's always going to go last. Why isn't it what now?
The one side why isn't it like -3? Because up there at the top it was see how it's 10 to the -2. You see what I'm talking about?
Yes, right here.
Yeah, and then the exponent was -2, so that was in -3.
Because of the 1/3?
Yeah.
I think she's asking like why wouldn't the 1/3 be negative?
Like why wouldn't it be -3?
The -3 would just move the base to the bottom. Like if I had 27 to the -3, that would just make 1 over 27 to the third.
Okay, I see.
Is that what you're asking?
Yeah, because at the top when it was in a fraction, I just went off of how the exponent was -2. So I thought that.
Gotcha. I think you're thinking of like evaluating. This one's just writing in a different form,
Okay.
maybe?
That's what you said.
Okay. Now we're getting into evaluating. So it's pretty much the same thing we did up here. Okay? So the first thing we're going to do is write this in exponential form. But you notice it has no equal sign on this one, right? So let's put an equal sign. It does not have an equal sign, so we're just going to put equal to. We don't know what it's equal to, so of course we can put an x. Now tell me how to write this in exponential form. 3 to the 3 to the what? Equals. Good. And so we're looking for what power of 3 can we raise that 3 to get 243? I want you to try to find it on your own. And then just say it out loud whenever you find it. 5. Okay, now Kelsey, tell them how you went about finding that. Yeah. That's right.
Wait, are you serious?
No, you can't. No, on your test you won't be able to.
Use what?
Don't worry about what he said.
What would you say about?
You'll learn it later.
Wait, what?
Antonio. Enough. You take 3 and raise it to, you know it's not going to be the second power, you know it's not going to be the third power, because you should know that's 9 and 27. It's going to be greater. So you could just try 3 to the 4th. That's not it. It's got to be higher. So try 3 to the 5th. There it is. So x is 5. Alright, Darian, tell me how to write this one in exponential form.
2 x
Equals.
16.
Alright, go ahead and tell me what x would be.
4.
Everybody agree? 2 to the 4th? Very good. Alright, you're going to do 1 or 3 of these on your own. Do you want to do one more on your own, or together, or do you think you can do all 4 of them on your own?
No.
Which one together?
14.
14. Alright, if you can go ahead. This one, let's rewrite this. Well, first of all, does everybody know what cube root of 7, or the 7th root of 3, how to write that in exponential form?
No.
Okay, what is this exponent of 3 right here?
Hold on.
Sorry. 1. Everybody see that? This is the same as 3 to the 1/7 power.
Oh.
And the easiest way to remember it, this 7 is a root, correct? Think about trees, how they have roots. They go up from the bottom, right? So your root will always go on the bottom. Exponent goes on top. So let's try another one. This 5th root of 2 is the same thing as 2 raised to the what power? 1/5. Good. The 1 came from the exponent, 5 came from the root. Let's try one more. What about the cube root of 4 squared? This would be 4 to the what? 2/3. Does everybody understand? Okay, so when you're writing this in exponential form, this is going to be 3 to the x. We don't have an exponent, so equals 3 to the what? 1/7.
Why
And
would
if-
you put the 3?
Because that's what this is, 3 to the 1/7. Just like we brought down the 16 right here, we got to put this right here.
Okay.
Okay, and now, so what would I have to raise 3 to get 3 to the 1/7? It's kind of rhetorical. It's just 1/7. So if you'll notice, these have the same bases, right? We could just cancel them out and write x equals 1/7. Yeah. All right, I want you to try 11, 12, and 15 on your own. Or 13, excuse me. 11, 12, and 13.
So let's try to write this as 5 squared instead of 25. Bring down the x with it. And this says it's 5 to the first power. And remember how these could cancel out and just have x equals 1. These are like 2x equals 1. Now solve for x. We're about to go with that.
We'll go up together. Anybody have number 11? -2. Very good. Do I need to go over in depth how we got that? Okay. This is 7 to the x power equals 1/49. So we know it has to have a negative exponent because it's a fraction.
Yes.
So what do you have to raise 7 to get 49? 2. It's in a fraction form, so you know it's got to be a -2. Very good. What'd y'all get for this one?
1/5.
Do I need to go over it? Very good. Alright, y'all were kind of stumped up on this one, so let me show you the best way to do this one, okay? Write it in exponential form, or tell me how to write it in exponential form.
25 raised to the x. 5.
Alright, if you can't think of it off the top of your head, and some people can, and that's fine, you can change these where they'll have the same base. Okay, just like this one, so that way you can cancel them out and set the exponents equal to each other. So what is a number that you can raise power to get 25? You can raise 5 to the what power? Rewrite 25 as 5 squared. We also have to bring down that x, right? So 5 squared is the same as 25. I just brought down the x.
So it's going to be 5.
And this is going to be 5 to the first power, right? I don't have to change it. So now the bases cancel out. We'll have 2x equals 1. And now we just divide everything by what? So x equals, very good. But if you can just look at it and just see that it's going to be 1/2, you don't have to change it to the same basis, okay? Alright, flip it over. Alright, more graphing. But good news on these. If you don't know where the log button is on your calculator, or if you didn't have a graphing calculator, you wouldn't be able to graph these. Okay, so I'm going to show you how to do it without a graphing calculator. All you have to remember are these 3 points. Write these down under determine the points.
Everybody?
No, just if you want to learn and pass this class. Those points. 1, 0, b1, negative 1, or 1 over b, negative 1. I know it looks weird, but these will always be on a log function. Always, these points. You just have to fill in the b, the missing letter. And what do you think b stands for? Base. What's the base of this one? So the first point is going to be just 1, 0. That's on every single one of them. 1, 0. The next one is going to be 3, 1. Good. And 1 over 3, negative 1. Now all you have to do is plot those 3 points and graph. So graph 1, 0. 3, 1. Already messed up. 1, 0, 3, 1. And then 1/3, negative 1 is going to be right about there. And it's going to look like this every time. And that's all. You will have to memorize these, but here's a quick way, I guess. 1, 0, just remember that's always going to be on there. B1, and then flip the B, change the sign. Flip the B, change the sign. So you'll just have to remember those 3 right here when you graph them. Let's do one more together. What's the base of this one? 1/4. The points are 0, 1, B1, 1 over B, negative 1. Every time. It is. Off my game. Thank you, Colby. So it's going to be 1, 0. What's my next point? Yeah, and if you want to, you can change that to a decimal if you're more comfortable graphing those. What is 1 divided by 1 over 4? 4. Good. 4, negative 1. Now all you have to do is graph these points. 0.251. 4, negative 1. There we go. And the only difference between this one and this one, it's kind of flipped upside down, and y'all know what determines that. It's if the base is a what? A fraction or a whole number. So if it's a fraction, it's going to be decreasing. If it's a whole number, it's going to be increasing. I want you to go ahead and do number 3 on your own. And then I'm going to borrow some nice paper. Yep, just that one for now. Alright, here were the 3 points Colby came up with. 1, 0, 5, 1, and he changed this to 0.2, negative 1. Here's what his graph looks like. Is that what y'all's looks like? Very good. So everybody's good with graphing logs. Okay. Flip it over. So now the transformations, they kind of look ugly, and you're thinking, gosh, I have to make a table, but you don't. You just have to graph those 3 points again. But this time, you're going to list those 3 points for the parent graph, which is just log 6 of x. So the base is what?
6.
What's 1 point that's going to be on there? Does anybody remember the next one without looking? 6 what?
1.
Okay, good. Next one? Good. Y'all got this. Don't graph those. Don't graph them. Don't graph them. Don't graph them. Alright, now we're going to use our transformations to change our points. Alright, we know the 1 is going to move at what? Down. Moving our what value? X or Y? Y. Down, up and down is talking about Y values. Alright, the 1/3 is just multiplying, right? Multiplying your Y values by 1/3. So, does the X values, are they going to change?
Yes.
We're going to multiply this by our Y values. That changes our Y values. This changes our Y values. So, are the X values going to change? So, right, 1, 6, 1 over 6. Excuse me. And now you're going to take this Y value, which is 0, correct? What is 0 times 1/3?
0.
Minus 1?
Negative 1.
Everybody see that? So you just take your Y value, multiply it by 1/3, and then subtract 1. So what's 1 times 1/3? 1/3. What is 1/3 minus 1? Negative 0.667. Find your last Y value on your own. What'd you get? Good. Now graph these points. These points. Questions? Isn't that a lot easier than transforming it? I feel like having to graph the parent graph and move them. Alright, one more together, then you'll do one more on your own. This 2 is affecting what? Your X or Y? X, because it's grouped with X. And remember, X is a joker, so instead of adding 2 to our X values, we're going to do what? Subtract 2 from what values? X. The 4 is being multiplied by what values? Good. Multiply your Y values. Before we do that, we have to figure out our points for this base, which is what? 1/3. But the first one is 1, 0. What's the next one going to be? 1/3 what? Good. Next one? Perfect. Let's do this first one together. Alright, what's 1 minus 2? Good. And then what is this 0 times 4? Transform your other points. Again, I am subtracting 2 from the x's and then just multiplying your y's by 4. And I heard from people last time that took the ACT that there was a lot of exponential / log stuff on there. So after we do this, if you are still planning on taking your ACT again, wait till we're finished with this unit. So take it in January or February or March or sometime in the spring, okay?
I think the last test they looked at in December,
The last what now?
Next one's December.
For us, it'd be December.
Oh, it is?
It's the last one I look at.
Well, at least you get an intro to it.
Yeah.
We won't be probably done with the unit before that test date.
But
But
the way we look at SAT, like, ACT, like, get multiplied.
go ahead and finish this.
We out entire week Thanksgiving.
It's courses Monday
Nope.
and Tuesday that we come to school, and then we have those 3 days.
Alright, once you have finished these 2 problems and I've checked that they are correct, you can pack up.